Hi, Geometry. This is Unit 3, Lesson 3, Part 2, and I'm on page 329 of our books. So we're going to dilate this quadrilateral ABCD using center P and your scale factor. So let's use a scale factor of 1/2 to practice that some more. The steps for this are on page 326. So the first thing I'm going to do is lightly draw a line from my center through all 4 of my vertices, very lightly, because this isn't any part of my answer. This is how I get my answers, but it's not part of my answers. So just really lightly draw a line that goes through all 4 vertices from your center P. I know that A prime, C prime, B prime, D prime will be somewhere along those lines I just drew. So let's find out where they go. So I'm going to measure these segments. I'm going to be doing part 1 and part 2 at the same time. This table are about the distances from the center to each vertice. So I'm going to go ahead and as I measure, I'm going to be writing the answers in there too to save time. So let's begin with PD. So I measure from P to D, and it looks to me like it's 1 tick mark after 3.5. So this is 1, 2, 3.5 centimeters, and I look like I'm 1 tick mark after that. So that's like 3.6 centimeters multiplied by 10, that's 36 millimeters. So it looks like PD, notice that in my ratio, PD is on the bottom. PD is 36 centimeters. So now let's figure out where D prime is. If my scale factor is 1/2, remember the length of my image side is going to be my scale factor times my original length. That we learned that in an earlier lesson. So my image is going to be equal to 1/2 times my original length. Well, if my original length is 36, then my image length is 18. So here we go. 18. How do I do that? Well, 18 is 1 centimeter and 8 tick marks. So 3 on the other side of 5, or 2 tick marks before the 2. That's where my 18 would be. Oh. So this is my D prime. Made a little. So now let's do B. So when I measure B, it looks to me like it's not quite 4.5. I'm at the 4th tick mark. So that is 40 millimeters and 1, 2, 3, 4 more. So 44 millimeters from P to B. So P to B, PB is in the bottom, so that's 44. And then half of 44 would be 22. So it looks like from P to B prime would be 22. So let's measure that out. I'm gonna go to 20 and then 2 more tick marks. So I'm about right here. That's going to be my B prime. And I know from P to B prime was 22. Let's do PA next. PA looks like it is 2 tick marks on the other side of 4. So that's 40 centimeters and 1, 2. So 42 millimeters, sorry. So PA looks like it's 42 millimeters, and 42 times 1/2 would be 21. So let's go mark A prime at 21. So 2 and 1 more would be about right here, and that's my A prime. And I know that P to A prime would be 21. And then let's do P to C. So P to C looks like it's 15. So it's 15, half of 15 is 7.5. Oh my gosh, how do I do 7.5? So 7.5 millimeters. I'm going to go 7 tick marks. And then I'm going to just put a dot between the 7th tick mark and the 8th tick mark. And that's somewhere right in there is 7.5. And that's my C prime. So then I knew from P to C was 15, and P to C prime was half that, or 7.5. Let's connect those. So I'm going to connect my prime. I'm going to use a purple that's not quite so inky. That was kind of making a mess on my paper. So I connect my A prime, B prime, C prime, and D prime. When I do that, I get my image quadrilateral on my picture, and I know that ABCD is similar to A prime, B prime, C prime, D prime. Look what else I noticed. I was learning in the last part of the lesson that my sides should be parallel to each other, and it certainly looks like they are. For instance, A prime, B prime does indeed look parallel to AB. In fact, all four of the sides look parallel to the other one. So let's go back to, fill in your 18 if you didn't hear for PD prime. So notice all these ratios equal 1/2, and that's the scale factor. And that's happening because all of my lengths are in proportion. So what do you notice and what's your conjecture? So in this problem, each ratio, which is the image length from the center divided by the original point's length from the center, was equal to the scale factor. And again, that's because my lengths are in proportion. And if you're wondering why I didn't say sides, because none of these lengths up here were my sides. These are lengths from the center. So in this table, we're going to do a couple side lengths, and then I'm going to write this again, that my sides are in proportion. That's really what I want you to have just memorized, is that your side lengths are in proportion. Everything about your picture got smaller by the same scale factor of 1/2. The distances from your center, your side lengths, your diagonals, everything changed. Everything that's a length changed by the scale factor of 1/2. So let's look at one more table. We're going to partially fill it in. B prime A prime over BA, this is side length. I should get a 1/2 here. So let's go see. Let's go measure the original AB. My original AB looks to be about 3 centimeters or 30 millimeters. So let's put that in here for my BA. And then let's go see what A prime, B prime looks like. It looks like from A prime to B prime is 1.5 centimeters, which is 15 millimeters. So perfect, actually. 15 over 30, I know I'm going to get a 1/2. This is the image over the original. My sides are in proportion. They are in proportion by my scale factor of 1/2. Sorry, I think you couldn't see that time when I measured it. Sorry about that. When I measure from A prime to B prime, I noticed that it was 15 millimeters. So let's do a diagonal. So this one is actually a diagonal going from C to B. So let's measure that. So C is here and B is down here. When I measure from C to B, it looks like it's 30. It looks like it's 3 centimeters or 30 millimeters. So let's put that in my table. And then let's go do C prime, B prime. I need to slide my paper down a little bit so you can see my C prime. So that is a diagonal of my image. So start at C and go to B prime. It does indeed look like I'm at 1.5. That would be 15 millimeters. 1.5 centimeters is 15 millimeters. So let's go put that in my table. So both of those equal 1/2. All of these measurements should be approximately 1/2 or 0.5 if you guys are depending on your calculators there, because the scale factor is 1/2, and I know that my sides or my lengths are in proportion. Everything in my dilation changed by my scale factor. However, that's my sides and my lengths. The other thing that I need you to make sure that you realize, let me get a different color. We'll use green, a special note down here. My angles are congruent. So my angles are not changing measurement. For example, angle C is congruent to angle C prime. Angle A is congruent to angle A prime. Angle B is congruent to angle B prime. And angle D is congruent to angle D prime. My angle measures have not changed. My new angles are not half of my originals. It's just all the different lengths in my dilation. So each ratio, it says, what did you notice? On this page, every ratio, so each ratio that we did, didn't matter what it was, each ratio that we did, that was each fraction that you saw in our tables. Each fraction is approximately equal to the scale factor. And that's because all of my lengths are in proportion. Okay, ladies and gentlemen, so that ends the notes for this lesson. I will see you in Zoom. Thank you.